Hey, what's up guys, my name is Cherno and welcome to the next episode of the Serialization series. So, last time we went over all of the different things that we needed to write out floats, doubles, and booleans, okay? And we also covered some pretty cool stuff about bit fills and how we can actually combine multiple booleans into a single byte, because of course they do only take up one bit of actual data. Anyway, today what we're going to do is we're going to kind of wrap off this serialization writer class because it's looking pretty good right now. There are very, very few things missing, but essentially we want to be able to write out strings somehow, and then also stuff like just byte arrays and arrays in general, okay? Those are the kind of things that we kind of want the ability to write out. So, strings, okay? Strings are generally pretty easy to write. The reason strings are, and we've actually done that kind of once. If you actually scroll up to the top here, you'll see that rc.getBytes, we kind of did actually use a string, then we used the getBytes method here to essentially return ourselves a byte array, okay? So that's basically the idea behind writing strings. Yeah, it's pretty simple, okay? However, that's not really the proper way to do that unless you really know what the length is. When we write this out, this will be 2 bytes, okay? And that's fine. That's totally okay, because we know it's going to be 2 bytes because it's our header, and we know that we're going to have like a 2-byte identifier at the beginning of our file format. That's fine, but however, we don't normally know how long a string is, right? You can't just be like, okay, all strings are, 8 characters long or something. It doesn't make any sense, right? So what we need to do is somehow have we need to somehow encode into this string how long it actually is, so that we can retrieve the right number of characters. Because we could just keep going. If we don't know how long the string is, we can just kind of keep reading and never hit the end until we run out of the file. Like literally, okay? So we need a way to be able to say that, okay, the string is this long, I need to read this many bytes into a string, and that's all I need to do, okay? So that's what we're gonna cover today, and we're also going to hopefully have enough time to cover the reverse of this. So we've gone from how to go from values such as floats, longs, integers, all these types into byte arrays, but what about the reverse? How do we actually basically go from having a byte array back into a float and all of that stuff as well? Because of course writing is nice, but we need to also do the reverse of that, which is reading. So strings, right? Really easy to do. Let's just kind of write what we want to do. We've got a string here called name. Name will be Cherno. And then we basically want to do something like we did before, which is just pointer. Let's just make this like a bit longer. Might make it. We can just get rid of this stuff. So we'll maybe keep the 2 booleans there just for fun, but we will get rid of the long, okay? So we've got plenty of space left. We just want to kind of do write bytes, data, pointer, and name, okay? So how do we write that string out? Well, what we'll do is we'll actually make a special method out of this that actually writes the length as well. So what we can do here is we'll make a method called writeBytes. Well, of course, we'll have a destination, the pointer, and then the actual string. So string. And we've actually got a few options here. Okay, we could do one of 2 things, and we could also do both of them. Okay, the first thing we could do is simply write the size before the string. Okay, that's pretty simple. So in other words, if we literally had the letters Cherno before that, we might write something like 6, okay? And then maybe, typically 1 byte probably isn't enough, because that really only limits us to 255 characters of the string, if that was an unsigned byte. So usually you might have a short, okay? So in this case, that short might be 06, and then we have like, so that's 2 bytes, of course, and then we have 1 byte for each character or something like that, all right? And if we were to group this in 2 bytes, then it would look something like that, okay? We could do that. That's pretty popular. I actually like doing it that way, and then we obviously know that when we read this, we know that the next 6 bytes, 1, 2, 3, 4, 5, 6, will be our entire string, okay? The other thing we could do is actually have a null termination character. Okay, what this means is that at the end of our string, we simply have a 0. okay? And a 0 means that we've reached the end of our string, okay? Now this is literally going to be like a 0 in like binary, okay? This is very different than the actual character 0, which has a completely different number, or a completely different byte representation, right? It's not just 0, right? So there you go. And also, I was kind of writing this as one thing I want you guys to notice, that I was kind of writing this in 2-byte chunks, which probably wasn't correct, because you might be confusing this with hexadecimal or whatnot. Obviously, in my representation here, for example, this was kind of taking up. Actually, no, that could work as well. But I would kind of, instead of being like, instead of taking up 4 bits, I was kind of taking out 1 byte per digit here, per thing, okay? Instead of 4 bits. So don't confuse that with hex or anything. But anyway, that being said, that's what you could do, okay? So you would have essentially a single byte termination character at the end of that, okay? And there you go, you're done. You could also have both, almost like as a safety precaution. So in this case, you could have something like 06, then Cherno, and then a null termination character at the end as well. That's fine, okay? And that's it. So we're going to actually go with the first option, just because I prefer the first option. I think it's a good idea. Yeah, I like the idea of knowing how long the string is before we read it, because if you go with this option, then you obviously just kind of keep reading the string until you reach that null termination character. It's kind of called a null and a termination character because it is a termination character, and the value of the termination character is null, 0, meaning that it's the string has been terminated. But anyway, that's kind of the way that we can do this. So we're going to choose the first option. So to do that, we need to first of all write out a short of the length of the string. So we'll say, we'll just do write, we'll go pointer equals write bytes. It's going to be the destination, of course, the pointer, and the value here will be casted to a short the length of the string. So just string.length. Okay, so that's that written out. And then finally, we need to simply write out the byte array. So one of the things that we don't have here, which I'm going to actually have in a minute here, is the ability to write out just a byte array. Okay, so we need to essentially have like a bit of a mem copy, so that we can copy anything in a source byte array into this destination byte array. Okay, so let's write that quickly, because I'm actually surprised we don't have that. We'll put it at the very top, or in fact maybe after this byte, or maybe not, at the very top. Public static int write bytes. So this will be destination int pointer, and then source as well. So this is very similar to the kind of C style mem copy, except the parameters are a bit different. But anyway, the idea here is that we'll simply do something like for int I equals 0, or rather, we can just do something like for int I equals, yeah, we'll do 0. I is less than source dot length I++, and then we'll simply do something like destination pointer ++ equals source I. Okay, and then we'll return pointer. So very, very simple. It just literally will go through everything and copy. You could use something called system array copy, which just takes in the source, which in this case would be, source position, which would be 0, destination position, which would be pointer, and length, which would be source.length. And you could do that. That's actually closer to kind of mem copy, and that probably is a mem copy, to be honest. It's a native function. It's probably resolves to a mem copy. But we're just going to do it this way because it'll probably get, I imagine this will get compiled into something that is a mem copy, but I have no idea how the Java virtual machine works under the hood. It's obviously a lot more complicated than something like native code, but anyway, it'll be fine for our purposes at least. So, in fact, if you guys want to do some benchmarks and figure out what's faster, that's fine. For me, these benchmarks have always ended up being virtual machine implementation specific. So different platforms will yield different results. And different versions of Java will behave differently. It's just a bit of a nightmare, really. Feel free though to. I've shown you both ways to do something as simple as that, and you can do it any way you like. So, return write bytes destination, pointer, and of course, string.getBytes. Okay, sweet. So there we go. And if we want to verify something like that, I'm actually going to just clear like all of this because I don't really want it to get in the way here, but we'll just do something like write bytes, data, 0, and name, and then we'll print bytes and we'll see what we actually get. So first of all, that should take up around, well, I would imagine this would take up 8 bytes. But we've got 16 here, so let's kind of just, let's put it to 8, or 9 in fact, and we'll see what happens. Okay, so we've got the 6, okay, of course it's a short, which is why the first one you see here is 0, but that number is 6, just like I kind of laid out there. And then we've got these bytes that make up Cherno, hopefully. I'm not going to verify it, but we'll assume, like 43 seems about right, since we know that the letter A, capital letter A, is 41 in hexadecimal. But anyway, and you can look up some kind of ASCII chart or whatever you want to figure out exactly what it is. But there we have it. Okay, 1, 2, 3, 4, 5, 6 bytes, which make up the word Cherno here, and of course the 0 is just the last byte. If we get rid of that, then we've got that. Okay, so we know immediately that we have 6 bytes to read, and the following bytes are the bytes that we want to read. Okay, awesome. So there's the string. Now, let's make the reverse of all these, okay? A lot of them are going to be pretty simple, such as, for example, like this byte situation here is kind of going to be exactly the same, because we can just kind of look up the byte array and look at one particular index in that byte array, and that will actually be that byte. So there might not even be a need to do something like that, but we'll probably write functions for this anyway. So public static int read int. Now we'll have to obviously name them separate things because we can't distinguish methods by return type alone. But we'll start with int, why not? So we'll have the source, we'll have the pointer, and that's it. Okay, so that's all we need, source and a pointer. So to read an int, okay, this is where the fun begins. All we really have to do is read 4 bytes from this source at index pointer, okay? And then all them together to make that integer. So if we had an integer in binary, let's just say it was number, let's just say, I don't know what this is going to be obviously, but let's just say that in hex, our representation looks something like this, okay? What we want to do is we want to take all of these separate bytes and essentially combine them into a single integer, or a single kind of 32-byte, 32-bit kind of value. Obviously, in memory and whatnot, these are going to stay the same, okay? Well, in this case, we'll actually copy them, but the point is that they'll stay the same. So we're just kind of telling Java, hey, this is how our, this is what our byte array means. These are what these 4 bytes mean. They are an integer. I'm telling you they're an integer, and you're going to have to trust me on that, okay? They could be a float, obviously. They could be anything. We don't know what they are, okay? It's up to our format to tell us what type they are, and we're going to talk about types and whatnot next video. But essentially, again, in something like C++, it would be simple. It would be as simple as doing something called a type pun, okay, or type punning, which means that we basically tell the compiler, hey, the memory, the data at this memory address is an integer, okay, and we're done essentially, because types are not a real thing, right? If you look at memory, it's just a bunch of bytes, and it's literally up for interpretation. But in Java, we have to do something a bit differently. We actually have to construct an integer out of these bytes. So to do that, it's very simple. All we have to do is go through each of these. We know that the first byte here, I'll bring back our little thing here. Whoops. We know that the first byte here is actually the most significant byte, okay? Which means that it kind of belongs, it needs to, if we were to combine these, we would get something like this, right? Since this is the least significant byte and this is the most significant byte, this is kind of, if you go back to the video where we talked about bit shifting and whatnot, we need to kind of shift this all the way up, because if we were to kind of mask this, you know that we would get something like this, right? And by mask this, I just mean if we were to if we were to try and separate this, it would be followed by a bunch of zeros, and I'm actually missing one, because it is kind of the most significant byte, right? All that really means in practice is that when we actually get that, we don't need to mask it by anything. All we really need to do is read source pointer, so the first byte that we read is the most significant byte, right? Big endian. If we read this, when we do read it, we just need to kind of move it up 24 places. 24 places because 3 bytes, and 3 bytes times 8 bits to make a byte. 3 times 8 is 24. Okay, and then we just need to OR that with source pointer plus 1 shifted 16, and then OR it again with source pointer plus 2, 8, and then finally OR it with source pointer plus 3. Okay, and then finally we need to cast that entire thing into an integer. All right, and I might just kind of group these just so we know the order of operations here. And I'm actually not sure what it will choose to do, but anyway, once we've got that, we can just return that, and there you go. That's a very long line of code, but that's essentially how we read an integer from a bunch of bytes. Okay, so just to test this out real quick, what we'll do is we'll write out an integer, so such as 505. Let's see what that is in binary. So it's these 4. We'll take these 4. We'll make a byte array called bytes. We will add commas. There's our byte array. And then we'll change this to say read int bytes 0. And then we'll just kind of print that, I think. I'll get rid of that. All right. Yeah, this is a really big problem actually, because see, this is why I'm not a big fan of Java, because unfortunately, the bytes in Java are actually signed, which means that they go from -128 to +127 instead of an unsigned byte, which would go from 0 to 255, which is typically how you would represent things. So honestly, I don't even know what to do in this case, because when you read it from a file, it will kind of sort itself out naturally. But I mean, if we cast that to a byte, that probably just won't work. We'll see what happens. Yeah, we got -7. Great. So that's a bad example. Let's try something different. And there probably is a way to do it. I just don't know what it is. Because I don't really do this stuff in Java ever. But we'll do something like, we'll write a byte into data, call maybe like, so 500 that was. Let's do something like, okay, let's do like 1,000. That should be kind of reasonable. Bytes. Okay, so let's print that. Kind of comment that out for now. If we print that, we'll get, okay, E8, that's way too high again. Most of these are actually going to be a bit too high. I'm going to kind of try and hit, let's see, D0. Just shooting in the, just blindly shooting here. DC, it's too high. Okay, you know what? Let's keep it simple. Let's write out 100. We know that that's 64. This is actually just not. This is just going to be really boring, because okay, that will work. So back here we go. Apologies for the flailing, as I'll call it. But okay, so now we've got this byte thing that we want to read out into an integer, and if we were to read it, we should get the value of like 10,000 or whatever we entered there. Okay, there we go, 10,000. So read int clearly works properly, and that is all we wanted to really test. Okay, read short, of course, is going to be kind of the same thing. It's going to return a short. Whoops. And it's kind of going to do the same thing, except we're just going to cut the first 2 out of there. So it's just that and that. So no offset there, and an offset of 1 for the end. Read byte. We don't really need this, but we'll have it anyway, just for the sake of having a complete API, I guess. And then this will literally just be return source pointer. Again, you don't really need this. It's probably a bit silly to do it this way, but why not? We'll have char as well. Again, char is going to work exactly the same way. as this. In fact, it is literally the same thing. We're just changing the type. Okay, done. Now the long is, of course, just going to be the int, except twice as long. So read long. This is actually just a bit annoying, really, but let's take this whole thing, we'll turn it into a long first of all, and add one of these. I'll actually just drop this down a line because it's way too long. So +1, +2, +3, this will be +4, +5, +6, and +7. Okay, we'll change this to be 60. Yeah, that's correct. So 60, 52, no, wait, what am I talking about? 56. So 64 bits is long, so 64 minus 8 is 56. 48, for some reason I thought it was 6 instead of, anyway. 48, 40, 32, 30, and I've made a mistake somewhere. What have I done? No, that seems right. 24, 16. Clearly I've made a mistake somewhere though. What have I done? 1, 2, 3, 4, 5, 6, 7, 8. What have I done? Oh. Okay, well firstly that. Secondly, I'm actually just really confused right now. It's just not adding up. Oh, 32 and then to 30. Well, look at that. Aren't I just the smartest person in the world? 16, 8, and then 0. Okay, I don't know what I did there. I don't know how I did that. But anyway, that's not the point. Long day. Long day. Get it? Yeah, see, I can still be funny. Anyway, all that aside, that's how you read it long. Okay? Finally, we have the float and the... We've only got 3 things left, right? We've got the float, we've got the double, and we've got the boolean. So, source... And you can kind of probably figure the rest out by yourself, but of course I'm going to show you anyway, because I'm cool like that. So here, we just need to basically do the opposite, which was float dot int bits to float, okay? We take in, we essentially read the int first. Just getting a bit wasteful. I wonder if there's a way just to read it straight from binary. What do we have here? What are the constructors? So string, yeah, okay, so there's really no, yeah, okay, doesn't matter. If anyone knows, let me know, I'm not going to spend too much time on this. But we can just read an int, of course, being source pointer, and then cast that to a float, and then just return that. So it's actually quite easy. Double will kind of be the same. And not really cast it to a float, just call the float int bits to float thing. Read double, so of course we'll change this to be read long. We'll change this to be double dot long bits to double, and we're done. Okay, and then finally for booleans, as you can probably imagine, static boolean read boolean byte source int pointer. All we have to do is basically return source pointer. If it's 1, we'll just return, well, yeah, we can just return that. The problem with this is that if it's anything but 1, it will be false, which is also kind of wrong. So typically in the kind of Boolean way of things, you would return something like that doesn't equal 0 instead. Okay, and then that will kind of, you kind of call that your boolean. Okay, you could always add an assertion here that says something like source pointer equals 0 or source pointer equals 1. Okay, which just makes sure that it's either 0 or 1. But in general, you know, the way that booleans behave in something like C and C++ is, of course, any non-zero value is kind of considered true. Okay, so there you go. Anyway, that's pretty much it. this is pretty good. We've established a very good foundation because we now have the ability to write out everything. Okay, any kind of data that comes our way, including even strings, we can just straight up just write out, which is awesome, okay? And you might think, but hang on, what about arrays? But arrays are okay, because arrays will just be a bunch of, like, for example, if we had an integer array, all that would be is a bunch of write byte ints, right? So it's a bunch of calls to this, essentially, with some kind of header which says how long the array is and all that stuff. So it's really, really simple, okay? Now, of course, these headers need to be structured in some way, which we'll talk about next time, but we'll also talk about, specifically next time, we'll talk about different types and how we can actually be like, hey, the data that will follow is an integer. Because when we're reading, we obviously need to be like, hey, which one of these do I call to get my appropriate thing, okay? But there we go. That's the complete, kind of complete serialization writer class. Which has all of our static write and read methods completed, which is awesome. Okay. If you enjoyed this video, you can support me on patreon.com/the Cherno. Hit the like button if you liked the video, and of course, slack.thecherno.com is the awesome place to hang out for real-time messaging with people just like you. Goodbye.